actually started making AI using this dataset. We have a test, train, validation folders, 600 images all up. You can see an example of non-seizure and yes seizure. So this is assuming labeling by an expert. That's our ground truth baseline. We trained a convolutional neural network 10 times. Got some weird results to begin with, and then it got improved. You can see the confusion matrix that essentially tells you how many false negatives and false positives there are. So there are 4 and 4 in this case. And then we got to a point where we had 0 false positives and 2 false negatives. And the last run did not improve. So essentially we're getting best results with run 9 of the training, the one before last one. And this tool just allows you to review the data, and it will show you all the misclassified images as well. So you can see what the neural net got wrong. Yeah, in this case there will be 4 and 4. So 4 that the true label was seizure, but the prediction was non-seizure, and the other way around where the true label was non-seizure and the prediction was seizure. So those will be false alarms, and yeah, those will require a lot of attention because it's not clear what exactly in this image caused the neural net to make a wrong prediction. But again, eventually on run 9 we got down to only 2 false negatives, so that's a pretty good result. And that will be a test accuracy of 96.6%, average training accuracy, average validation, so validation is higher than training, whatever that means. I would think whatever 10% is comparable, it's still within the noise level, even though it looks quite a lot. The real question is how well this will generalize onto another data set. So if we use the same algorithm, apply it to a different data, so different spectrogram images from a different device, different study, how well will this algorithm perform? It would be one of the main questions. The other important question is we need to make sure it's actually which the two questions are obviously related, but we need to make sure the algorithm is actually learning the right thing. So it's not some noise or the size of the image. They're meant to be all the same size. Yes, there will be different noise, but hopefully it's actually picking up on this slowing down of spiking activity that you see in most of the seizure labeled images. And we need to essentially make sure the convolutional neural network learned to find and discriminate that bit, the presence of or lack of this slowing down spiking effect during a seizure event. So go check it out. I'll pop it into the chat as well. Let me know what you think, or if you have done something similar. I do want to know.